Welcome to Chapter 2, Section 4, Solving Equations with Variables on Each Side. So, as the title suggests, you're going to have variables on each side, and the best way to show you how to do this is with multiple examples. Okay, so when you're presented with variables on both sides of the equation, what I recommend is taking a look and seeing which side has less of the variable. And that's usually the side that you want to eliminate the variable on. So on this side, I have 5 k's. On this side, I have 3 k's. So this side has the least amount, so I want to get rid of this term. Think of this as an entire term, 3 k's. Since there's nothing in front of this, I assume that it is positive. It's plus 3k, and the opposite of plus is minus. So I'm not going to subtract just the number 3, I am subtracting the entire term, 3k's. And if I subtract 3k's on one side of the equation, I must do it on the other. Now, on this side, 3k's minus 3k's, that's going to leave me with no k's. So all I have left is a minus 6, a negative 6. On this side, I still have my 2 plus. I haven't done anything with that yet. 5k's minus 3k's is going to be how many k's? 2. So now I have 2 plus 2k equals negative 6. Now I'm going to solve this like a multi-step equation, like we did before. I want to get rid of this 2 because it's on the same side as the variable. Since there's nothing in front of it, I know that it's positive, it's a plus 2. The opposite would be minus 2. Do that on both sides of the equal sign. Please don't have a minus 2 here and here. Once on both sides of the equal sign of the equation. These 2's cancel. I'm left with 2k. There's my equal sign. Negative 6 minus 2 is going to be negative 8. Almost done. 2 times k equals negative 8. The opposite of multiplication is division. So I divide both sides by 2. Times 2 divided by 2 cancel. I'm left with k equals, here signs are different, so the answer is negative, and 8 divided by 2 is 4. Negative 4, pardon me. Now, if you wanted to check your solution, you could take this negative 4 and replace the variable k with it. By doing so, on the left-hand side, you would have 2 plus 5 times negative 4. That would end up being 2 minus 20, and 2 minus 20 would be negative 18. On the right-hand side, you would have 3 times k minus 6. 3 times negative 4 would be negative 12, and negative 12 minus 6 is also negative 18. So it checks out. Next, we're going to look at an example where we have grouping symbols. Now, if you have grouping symbols, the first thing you need to do is get rid of them, and the way we get rid of them is by using distributive property and distributing whatever coefficient we have. So here, signs are the same. 6 times 5 is 30, so I have 30m. Here, signs are different, so I have minus 6 times 3 is 18. Now, here, when I'm multiplying by a fraction, it doesn't have to be as bad as you think. Essentially, multiplying by 1/3 is the same thing as dividing by 3. Let me show you. If I turn these into fractions by putting them over 1, when I multiply numerator times numerator, denominator times denominator, essentially what I would get is 24/3 m plus, and here, numerator times numerator, 12, denominator times denominator, 3. Now, let me rewrite this so we stay nice and neat, which is what I expect of you as well. 24 divided by 3 is 8. 12 divided by 3 is 4. So that's really not that bad. And eventually you get to the point where you can skip this middle step and go straight from here to here. Now, just like I showed you before, you look at the sides and you say which one has the least amount of the variable. I have 30 m's here, 8 m's here, so I want to get rid of this side. Since there's nothing in front of it, I know this is a positive 8m. The opposite of plus 8m is minus 8m. These cancel here, and I'm left just with a positive 4. There's my equal sign. 30 m's minus 8 m's is going to be 22 m's, and I still have my minus 18. That did not go anywhere. Now, to get rid of this minus 18, I'm going to add 18 to both sides. I'm left with 22 m's equals, and 4 plus 18 is 22. Divide both sides by 22, and hopefully by now you already know what the solution is. M equals 1. And again, if you'd like, you could insert 1 in for the variable in the original equation to check and verify your answer. Alright, now let's take a look at this one. I think you're going to find this interesting. So, we already know we have grouping symbols. The way we get rid of that is distributive property. So on the left, I'm still going to have 5x plus 5 equals. Now 3 times 5x is going to be 15x. 3 times negative 4, I'm going to have minus 12, and I have minus 10x's. Now, before I do anything, I need to simplify these like terms. So, I still have 5x plus 5 on the left. On the right, 15x's minus 10x's is going to leave 5x's, and I still have the minus 12. Now, remember, I said that you want to get rid of the x's from the side with the least amount. But look what we have here, 5x's on both the left and the right. If I subtract 5x's from both sides because I don't have a choice, here it cancels, here it cancels. I'm left with 5, and I'm left with negative 12. Does 5 equal negative 12? No. And since 5 does not equal negative 12, this equation has no solution. Now, let's take a look at this one. Again, I have to get rid of the grouping symbols. 3 times 2 is 6, so I end up with 6b minus 3, because 3 times 1 is 3, minus 7, that comes down. There's my equal sign, 6b minus 10. Now, negative 3 minus 7, if I wanted to combine these, which I should do before I do anything else, I end up with minus 10. Well, that's interesting. I have the same exact thing on both the left and the right side of the equal sign. When you have the same thing on both the left and the right hand side of the equal sign, ultimately, if I subtracted 6b from both sides or added 10 to both sides, I would ultimately end up with 0 equals 0, which tells me absolutely nothing about the value of b. So, since the expressions on each side are the same, this equation we call an identity. And an identity is true for all values of b. So that means you can put anything in for b and it works. So, again, this is true for all values of b. So I want you to notice the difference. If you come to an impasse such as this, where the left does not equal the right, there's no solution. If you end up with 0 equals 0, the exact same things on the left and the right, then it's called an identity, and it is true for all values of b. So just to summarize everything we've done in this lesson, first thing you're going to do is you're going to simplify the expressions on both sides of the equal sign. If you have to use distributive property, use it and simplify. Once you've done that, then you're going to use the addition or subtraction properties of equality to end up getting the variables just on one side and the numbers without variables on the other side. Simplify. Then use the multiplication or division property of equality to solve if you have to. Alrighty, I'll see you in class.